Today we will start sixth module. So the module's topic is uh, aspect-oriented patterns.
Don't buy that
Yeah.
banana shake again.
Yes, Silvitra John, URA 20 is 5023. Can you mute yourself? Yeah, thank you. So in this module, actually, we are going to see about different types of patterns. Patterns in the sense in terms of microservice architecture. As per our syllabus, we have like some couple of patterns. Okay, the first pattern is about your security patterns, and then we will study about observability patterns, and then we will study about refactoring, from monolithics to microservices. All right. So these are all some of the core topics we will be seeing in this particular module. All right. So firstly, we will see about the security patterns. Okay. So if I talk about security patterns, in our previous modules itself, we have studied about this authentication, authorization. So some of the familiar terms again we will come across in this particular module also. Okay. So here we focus mainly on developing secure services in the context of microservice architecture and some of the challenges that it presents. Okay. Now, as usual, security is a crucial point for protecting data and also to prevent the breaches. So here the main areas that has been covered here is authentication, authorization, auditing, and finally secure inter-process communication. Okay. Out of which authentication, authorization, auditing, okay, again, these points are very familiar to us. Again, the same meaning again we are going to see. Okay. So as usual, authentication means it ensures that the user or the system is who they claim to be. Okay. So that will be checked by the credentials like passwords or API keys. Okay. Then about authorization, it verifies whether the authenticated person can perform certain actions. So like role-based security. Okay, so we have seen if the person is authenticated, then he will be allowed inside the system, whether he is authorized to access the complete system or not, or we will give certain roles for the users. Okay, so in that way, we will get the authorization. And then about auditing, so it tracks what actions users or systems perform. Okay, so it is again based on security monitoring, customer support, and legal compliance. Okay, so again, this is about tracking of certain actions that has been performed from the user's end or the system's end. Then coming to the secure inter-process communication. So here we have applying this transport layer security. Okay, so here the communication between the services must be secure. So we are using some encryption protocols like transport layer security because services may also require authentication when interacting with each other. Okay, so for that purpose, we can use encryption protocols like this TLS. Okay, so here basically throughout this particular module, we will be studying one application called as FTGO. This FTGO is nothing but Food to Go incorporation. Actually, this is a fictional, an example. Okay, especially that is used in microservice architecture. So there is a fictional character called as Mary, who is known as the CTO of this FTGO application. So this is a fictional an application, example application. So here it has been used through how the security mechanisms in a monolith differ from what is required in a microservice-based architecture. Okay, so here we will just see about this FTGO. This is Food to Go. It is the online food delivery system application portal. Okay, so firstly, the first section that we are going to see is about how a monolithic application handles security and how users authenticate and make requests. Okay, so firstly, again, we are going to have the same, this FTGO application, but from the monolithic applications perspective. Okay, so here we have this particular, this block diagram. So I have given the explanation for this. So firstly, in this particular environment, here we are having this user authentication is one particular, one area. Then we have the session token, which is the another area. Okay. So firstly, we will have, excuse me. Right. So firstly, we will have the user authentication. So if I talk about this user authentication, then the users will be authenticated. Okay, so users like consumers, the staff, they must log into the application using their credentials. Okay, then once they log in, obviously the application generates a session token. Okay, a kind of ID. So we all know what is this, it has been stored as a cookies. Okay, so you know what is a cookie, right? So nowadays, whenever we open a certain browsers, okay, it is asking to accept cookies. Okay, similarly, when we are accessing from the security's point of view, security patterns, okay, so from the monolithic perspective, once we log in, the application, it generates a session token, which is stored as a cookie on their device. Then, what about the session token? The session token, it identifies the user during future interactions. Now, it is like something like a badge. That is what I told you. It is about something like a cookies. Okay. So it says that I am that particular person, so that users don't have to log in again for every action. Then again, every time the user makes a request, then the session token is sent along with the request to prove their identity. So it can be any request based on the application. So if a request is made, then this particular session token will be sent along with that particular request to prove the identity. Then in terms of security context, now inside the particular application, let us say this FTGO application, now there is a security context which holds the information about the user who has been logged in and what they are allowed to do. That is what their role-based authentication, okay, or role-based authorization. So based on their roles, he can be a consumer, or it can be a restaurant, courier, or even he can be an admin. So in terms of security context, so this context will hold this particular information about who the user is. So then this information is kept in a special place in the application called a session. So this session is tracked by the session token. Okay, so this is what from the security context. So why we are using this this session tokens. Okay, then coming to this authorization, the application will use the role-based authorization, meaning each type of user has different permissions. So we all know that. So every user can access the application, but once we are logged inside the application, then we will have certain roles. So maybe from the admin side, they will fix certain roles for every users. So yes, for example, a consumer can only access their orders, whereas an admin can access all the orders. Okay, so this is what about role-based. As usual, we have certain challenges in monolithic security. Obviously, in monolithic applications, the sessions are stored in memory. That means it takes the computer's temporary memory. Okay. So normally, if there are more requests or for a particular session onto the same server, then obviously there will be a load balancing that will be difficult to handle. Okay, so that is what a major challenge in terms of monolithic security. Okay, I have given the explanation about the figure that I have shared. You can see here, we can have, there is a post method used here. Post method is nothing but a user logs into the application using the credentials. So this is done through a post request. Okay, so from a browser's end or from a mobile application's end, so this is sent, okay, to the server. Then this FTGO application, it will verify the user's credential. If it is valid, then it creates a session token and responds with a session. It creates a session first, and then it responds with a session token. And then after receiving the session token, the user's browser automatically includes this token in every request they make to this FTGO application. That is what we have seen in the very first topics point. This session token, something called as the cookies. Okay, so that is used for every request they make in future. Okay, so if for example, if the user wants to check their order status, their browser sends a get request. So here we have a post method previously. Now we have a get method, which is a get request for the order information, and it includes the session ID. So whatever request is sent, now the session token will be sent along with the request, as we have seen. So this token tells the FTGO application who the user is, allowing it to fetch the correct data. Okay, so this is about, we are talking about our monolithic perspective. Now, in terms of implementing the security in a microservice environment, microservice architecture. Now, in terms of microservice architecture, now the security part is more complex. So we have to concentrate more on the security area. Why? Because now the system is, as usual, we know the system is made up of many small independent services, something unlike in a monolithic application. Now each service, it must handle its own security responsibilities. Okay, I'm getting some disturbances. All right, fine. So each service, it should handle its own security responsibilities. Now here we have a term called as this API gateway. So we know what is this API gateway. So this API gateway, it plays a crucial role in centralizing the security process to make it more manageable. So API gateway is nothing but it will be like a it will be like a mediator. Okay, so between the clients and the backend services. Okay, so that is what your API. So it is actually a middle layer which acts as a mediator between clients and the backend services. Okay, so that is what about your API gateway. But in terms of microservice architecture, now API gateway will be it plays a major role in centralizing the security process. All right. Now, in terms of microservice architecture, it is obviously it is in a distributed environment. So usually the external request will be handled by an API gateway. So we all know what is this API gateway. For instance, if I want to access a particular application, then it will ask for, the application will ask for an account. So obviously there will be some default account like login using Google or login using Microsoft or login using Facebook. So instead of creating a separate account, we can use this Google account itself. So for accessing through the Google account, now this API will play a major role as a mediator to contact our Google account and the application part. Okay, so it will be like a mediator. So now all the external requests are handled by this API gateway. So in terms of FTGO application, for example, a request to get an order's details, it might involve several services like order service, kitchen service, and accounting service. So all these three different services can be involved for one particular request. Okay, so for to handle this, this API gateway, it plays a major role. All right. Then here there are again certain challenges, especially in monolithic application. Security information can be stored in memory, as we have seen earlier. But in microservice architecture, each service is independent, as we all know that, so they can't share the memory. So there can be a centralized session. Okay. So in a monolithic application, sessions are often stored centrally. So, but this approach, it doesn't work well in microservices where services, they need to remain loosely coupled. Okay. So here again, there are certain challenges. So how we can handle this authentication in terms of microservices environment? Okay. Now, instead of each service handling authentication, now this API gateway, it will handle the authentication centrally. Okay, that is what in terms of handling authentication related to API gateway under microservice environment. So that means only authenticated requests are passed to the services, which reduces the risk of vulnerabilities. So API gateway also handles different types of clients, and it hides the complexity from the services. Now, how to handle authorization? Now, if a user is authenticated, the system also needs to ensure that they are authorized to perform specific actions. Okay. Now, this again can be handled either at the API gateway level or by the individual services level. So here this option is given. So once a particular user or the service is authenticated, then it will go into authorization. So once a user is authenticated, then the application or the system, they have to ensure what action that particular user is authorized to perform. So this can be handled from API gateway level, which is a centralized one, or by the individual services level, that can be a distributed one. This API gateway, they can block unauthorized users, so before they reach the services. While services, they can have more fine-grained control who can access what. So these are all certain general things. Now, in terms of microservices environment, here there are two types of issuing is given. One is using this JSON web tokens. Now, as we have already seen, this API gateway, it plays a major role, okay, when handling the security part. Now, this API gateway, it can issue this JWT, which is JSON web tokens, which is to pass the user identity and the roles between the services. So once a user is authenticated and authorized and entered into the system or entered into the application, immediately this API gateway, it can issue an ID, something called as a token. Okay, now this token, which contains all the necessary information about the user, and they are signed to prevent the tampering also. Now this JWT are efficient because services, they can validate them without needing to contact the API gateway each time, because this JWT is issued by this API gateway. So all the time, the services, they don't want to contact API gateway. Why? Because all the information given inside this, this JWT is issued by API gateway itself. But here there is one drawback. That means they can, this JWT cannot be revoked once it has been issued. Okay, but still it can be mitigated. Mitigated in the sense we can, we can lower the number of tokens that can be issued by using the short expiration times and refreshing tokens regularly. But as we have seen, once it has been issued, that cannot be revoked back. Okay, but we can use another, the concept called as using OAuth 2.0, which is again to have it is a protocol for handling this authentication and authorization in microservices. So here again, the token-based system only comes here. So here it uses this access tokens. Okay, often it is called as JWT, and it uses this refresh tokens to allow you services to validate and reissue tokens securely. Now this is the previous drawback has been overcome by this OAuth 2.0. Now it has this authorization server, so which handles authentication and issues access tokens, and it has resource server, that means the services which use this token to validate and authorize requests. Now here the API gateway acts as the client in this particular system when we are using this OAuth 2.0. Okay. See, regularly I'm getting some disturbances. I don't know why. All right. Fine. Some key takeaways now you have to understand from this particular part is API gateway, which will be responsible for authenticating users and issuing security tokens. Then services, they use these tokens to validate users and authorize their requests. We all know when the request is made, a token is sent along with the request. Okay. Now we can have certain standards like JWT, which is called as JSON Web Tokens, and OAuth 2.0 to handle the security efficiently across our microservices architecture. Okay. So this is about your security patterns. Then we will go to the second topic, which is called as the observability patterns.
So there are some people waiting outside. Can you let them in?
Yeah, I have already. They are already inside.
No, there are still people who couldn't enter yet.
But there are no people waiting here. I have
okay,
already.
Okay. Yeah.
Fine. Now, the second one is about, the next topic is about observability patterns. Here, observability patterns means how we are observing our services. Okay, so how to design an observable services in a microservice architecture. So here, the goal is to make sure the services can be monitored, troubleshot, and managed effectively in production. So previously we have seen about the security patterns. So how we can provide security to the application. Now we can see how that can be observed. Okay, so observed in the sense how it can be monitored, how it can be troubleshot, and how it can be managed. I think again, you can relate this particular topic with our previous modules where we have seen about monitoring microservices. Okay, so some topics here and there you can relate with the monitoring microservices. Here also we are going with the same FPGO application. Now, when we deploy a microservice like FPGO in production, now we need to track its performance and its health. Now, the basic or the fundamental monitoring aspects can be observing about the requests per second, then the resource utilization, and the errors and failures. Okay, so this is what the major fundamental, the parts of monitoring in terms of observability. For instance, requests per second means, let us talk about the same FTGO, that is what online food delivery. So we are ordering certain food products. Now, in per second, how many requests have been made in the application? Okay, so that is what your request per second. So we have to monitor the request per second. And then how about the resource utilization, something like CPU or about the memory, and observing about on the errors and the failures. Okay, so by implementing this observability patterns, we can monitor the services. We can generate alerts also when some problems arise, and it makes and make it easier to troubleshoot and fix issues. Okay. Now, here in observability patterns, here there are several patterns that help expose the internal workings of the services and makes them easier to monitor. Now, each pattern will have these two components. One is what is the responsibility of the developer and what is the responsibility of an operation. Okay, so here we will see about some 5 or 6 types of patterns in observability patterns. Now, in each pattern, we will have these 2 types of responsibilities. Now, what is this developer's responsibility? That means developers are responsible for making their services observable by implementing these patterns. So here in our coming slides, we are going to see some 5 or 6 types of patterns under observability patterns. Now, developers will be responsible for their services by implementing these patterns. Okay. Now, what is the responsibility of the operations? Now, operations teams, so they manage the infrastructure to collect and act on the data exposed by these patterns. Okay, for instance, we can use by using some monitoring tools also. So how by using the tools, how it has been monitored, how the data has been collected, what are all the manageable parts that has been taking place when in terms of operation. Okay, so the responsive patterns or the responsive actions that has to be taken. Okay, that is what the major responsibility from the operations perspective view. Okay, so here you can see there are some there are 1, 2, 3, 4, 5, 6 patterns. One is health check API pattern. Then we have a log aggregation pattern. Then we have distributed tracing pattern. Then we have application metrics pattern. Then we have exception tracking pattern. And then we have audit logging pattern. So here you can see the main key parameter. So here, this is what your pattern and what is the pattern participant. Okay. And what are the developer responsibility and what are the operations responsibilities. Okay, you can see something like this. Okay, so firstly, let us start with health check API pattern. So firstly, we will go with this one, health check API pattern. So what is the developer's responsibility? Okay, under health check API pattern. That means here an API should be implemented which reports the health status of the service. Health status of the service means if I'm having multiple services for an application, now this health check API pattern should be there to check the health status of that particular service, whether it is running or if there are any issues. Okay. Now, what is the operations responsibility? Now, operations responsibility is to monitor this API regularly by using any tool. That is what we have seen, by using a monitoring tool, or the service to ensure the service is healthy. Okay, that is what the operations responsibility for health check API pattern. Okay, so here an example: if a service is down or a disk is full, then this health check API can alert the operations team. Okay, so that is what that should be the case. Okay, whenever there is an issue. Okay, for that purpose only we are keeping this health check API pattern. Now we can see something more in detail about this health check. So this health check is an essential mechanism to monitor the health of a particular service in a microservice architecture. So it helps the deployment infrastructure to check whether a service instance is ready to handle requests or if it is facing any issues. Okay, it continuously checks the service ability to function correctly by running various tests. Okay, so this health check API, it will perform some background tests. Okay, so it continuously checks the service ability, whether it functions correctly or not. Okay, why this health check API is important? Okay, whenever we start a service, normally it may take some time to initialize the connection with external components like databases or message brokers. Now, during this particular time, the service is not ready to handle the request. Okay, that means if I am, let us assume, if I am opening or if I am just starting my FPGA consumer service, okay, normally it takes randomly 10 seconds to initialize. That means during that particular 10 seconds, any request should not be received. Okay, that means it should not receive any traffic before it is fully ready. So normally an application is completely loaded, and for complete loading it takes around 5 seconds to 10 seconds. So during this particular time, it should not receive any traffic before it is fully ready. Sometimes a service may appear to be running, but cannot handle requests due to issues like lost database connections. So for this purpose also, we are using this health check API. Okay, let us assume maybe from other end, the service may appear that it is running perfectly, but it cannot handle the request. That means if any request is coming, let us assume like 100 requests per second has come. Now the service seems to be running perfectly, but all these 100 requests per second that would not be received, okay, due to some database connectionless, okay, lost connection. Okay, so for that also we can have this health check API. So in that case, this health check would identify this particular failure. Okay, now you can see in an example, an error might cause the service to lose all database connections, making it unable to process the orders, but it has not crashed. Okay, that means the service seems to be working perfectly, but there are some internal errors. Now this health check API, which is being running continuously, so this will perfectly identify this particular failure. Okay, so I have given this block diagram for this health check API. So here, how this health check API works. So that is what it is given here in the block diagram. Firstly, the service exposes a health check endpoint. You can see here this health check endpoint. Okay, so which periodically it will be called, it will be invoked. Then we have health check request handler. You can see here, health check request handler. Okay, so this health check request handler, it will run the test to check the health of the service health, by verifying its connection to the infrastructure components. Normally, it should be connected with the database, and it should be connected with the message broker. Okay, based on these checks, now this health check API, it will respond with the responses called as HTTP 200, which says about healthy, or HTTP 503, which says it is unhealthy. Okay, you can see here. So this is what it will check for messaging adapter, and it will check for the database adapter. Okay, so this messaging adapter is about having the message broker, and database is about our database connections. Okay, so based on these checks, again, your health check API, it will give the responses whether it is healthy or not. So how the deployments infrastructure it uses. So we have a monitoring system, tools like service registries, Docker, or Kubernetes. They invoke the health check API to determine whether a service is healthy. Okay, now we have to implement this health check API. So for implementing this health check API, we can check the service ability to connect to critical components, like testing the database queries. Now, if I talk about a health check API, we have to check with the external infrastructure components. For instance, if I am checking with the order services, now this order services has to be connected with the database. Okay, now if I am implementing this health check API on my order services, now this my service has to have an ability to connect to the my database also. Okay, then a more advanced implementation, they can simulate a synthetic transaction by mimicking to have a real user would do to ensure the service works end to end. Okay, that is something like a mock test. Okay, then we can use some tools like Spring Boot Actuator, which is a monitoring tool. Okay, which provides a built-in health check mechanism, which automatically tests the infrastructure components like databases or message brokers. We can customize our health checks. That means developers, they can add some custom health checks to verify additional components also. Now we have seen some basic components like message adapter and database adapter. If the developer wants to add some more components, okay, which is relevant to the services, so that also can be done. We have this Spring in Spring Boot. The custom health checks can be implemented using a health indicator interface. So in the Spring Boot tool, we have this a customized interface. Then finally, this invocation of the health check. That means when we are calling this health check. Now it is essential to configure our deployment infrastructure to invoke the health check endpoint regularly. So we have to call this health check endpoint to determine whether if the service should receive traffic. There are some external tools also, so that can be set up to perform this check and manage the service based on its health status. So with this, your first pattern is over, which is your health check pattern. Okay. Then the next pattern is your log aggregation pattern. So this log aggregation pattern, maybe we can continue in our next class.